Okay, so we're going to do a little bit more of the integrating standard functions. Specifically, we're going to be looking at a bit more definite integrals and maybe something with a little bit of an element of problem solving in it. Before we do that though, at least one of these questions uses logs. So I thought, although we're not going to use it that much, but it's always good to have a refresher, I thought it'd be nice to ask you to try and remember as many of the log rules as you can. So a few hints there, I'm looking for stuff involving addition, multiplication. If you can remember it, change of base. There's at least 3 or 4. So pause the video, try and write down the log laws that you can remember, and then let's see if you get them. Okay, so just double checking, though, make sure we hit all the correct ones. So let's do multiplication. Now remember, technically with the log laws, it's good to be explicit in your base. So let's say base A. So hopefully you got the multiplication law, which is this. Base is the same throughout. Your division law. Base is the same throughout. The power law, which we use very often and is extremely useful and one of the nicest properties of logarithms. Part of the reason we use them, or why we invented them. And then one that many people forget, I think, which is the only one that uses a different base throughout the identity or throughout the expression. So if you've got log A of x, or sorry, let's say you want log A of x, but you've only got log B of x, this is effectively the transformation you need to do. You take your log B of x and you divide it by the log B of this A, this mystery A that you want it to be a base of, and then you'll get the left hand side. Right, so remember this thing on the bottom is actually just a constant. It's just a number, right, because A is a constant. Great, and then just a couple of standard results to throw in there as well, if you can call these laws. Log A of A is 1. For example, ln of E is 1, because that's log of base E, and log base A, sorry, of 0 is, not 0, of 1 is 0 regardless of base. Okay, cool. As I said, we're not going to be using all those, but good time to remind ourselves, I think. Okay, so I'm going to give you quite a few more questions to try. Let's just do another example together first, though. This is a definite integral. And you're going to be looking at a few questions like this, where you have a definite integral, but where the limits are not definite, as in they're unknowns, they're constants, you don't know what they are, and you want to find out what they are. So we've integrated this function between these two limits, a and 3a. What is the value of a, given that the area underneath the graph is ln of 12? So let's have a go at this. So I'm going to integrate from a to 3a, 2x plus 1 over x, I should say with respect to x. I'm going to divide everything through by x to give me expressions I can actually integrate. So 2x divided by x gives me 2, and 1 divided by x gives me 1 over x. So I get this. Let's do the integration now. So I'm switching to my square brackets. 2 goes up to 2x when I integrate. 1x goes up to ln of mod x. And my limits are now on the outside here. And that's therefore equal to 6a plus ln of 3a minus 2a plus ln of a. Notice they said here a is a positive constant. Oops, crossed it out, but I meant to underline positive constant. Therefore, I can get rid of these mod signs because the mod of a positive number is itself. So we can turn those into curvy brackets rather than straight ones. Okay, and then let's do the final simplification. 6a minus 2a is 4a. Then we've got plus ln of 3a minus ln a. And here's our first chance to use a log rule, perhaps. Let's just take a look here. Interesting. Okay. I hesitated for a moment because I thought I was going in the wrong direction, but actually it seems fine. Let's just trust ourselves. So we've got 4a ln 3a minus ln a. That's going to be the same as ln of 3a divided by a, which is 4a plus ln of 3. So that's nice. This has become a constant. Okay. And we're told that that final answer should be equal to ln 12. So let's make a note of that now. We worked out it was 4a plus ln 3, but they're saying it should be ln 12. Okay, and this was my moment of hesitation because I thought, hang on, how do I make that work? But we can make it work. Again, we just have to trust the mathematics of it. So let me just make some space first. So we're going to have 4a equals, and then let's take the ln 3 to the right hand side, taking it away. And now we've got another nice bit of log rule there. Ln 12 minus ln 3 is the same as ln of 12 over 3 equals ln of 4. And that implies that a equals, divide both sides by 4, you get a quarter ln of 4. And that's it, that's the answer, quarter ln 4, which is in fact a constant, right? So that's it, it is a number, type that in your calculator, you'd get what it would be. But of course we were asked to find an exact value, so we're happy with it as it is. I suppose you could technically also write this as ln of, and use another log rule, 4 to the quarter. That's an interesting one actually. Do you want to do that? The textbook says it's just quarter ln 4. I'm just a bit intrigued by that way of doing it. I quite like it actually, because 4 to the quarter, that's the same as 4 to the half, all to the half, isn't it? So that's basically just ln of, or 4 to the half is 2, so just ln of root 2, which looks a lot nicer actually. I quite like that. It's ln of root 2, or you can call it a quarter of ln 4. Quarter of ln 4 is what the book says. Okay, so let's look at some questions. It's just one page, but quite a few marks to be given there. These are sort of exam style questions. Just see how you do, give them a go. Look up the answers as well, obviously, make sure you're getting the right things, and if you're getting stuck, make sure you ask for help.